Okay, welcome to this month's virtual JBoss. So today we have Alex Laskovex, who's a software developer at Red Hat. Alex works on JBoss Data Grid, and today he's going to be talking to us about JGroups. So thanks for coming, Sebastian. I'll just hand over to you and let you introduce yourself and kick off your talk.
Yeah. So hey everyone, my name is Sebastian Laskovex. I work in Poland for Red Hat for over a year. Most of the time I work on Newcastle project, which is our brand new build system for Red Hat products. And I also work for JDG productization. So we actually take in Finispan bits and convert them into the product. So today, I hope I would like to take you for a journey and discover some basic things in JGroups framework, just to show you how to create a cluster, how to communicate, and do some very basic stuff. I hope you enjoy it.
Thanks, Sebastian. So, could share your desktop and start your talk?
Yeah. So, let's start with the presentation. Just let me share the screen. Okay. Can you see the slides?
Yeah, that's good.
Okay. So, as I said, I work for Red Hat for over a year. If you'd like to catch me, you can connect with me using Twitter or using emails. So let's dig in. JGroups. JGroups is a clustering library created by Bela Ban. He's from Switzerland. The jar is very small. It's only about 2 megabytes, and it doesn't have any external dependencies. So it is very easy to use. You just grab it from Nexus and just put it in your palm, and you're ready to go. The library provides you a reliable communication, both one-to-one and one-to-many. So unicast and multicast. Using this unicast or multicast, you can create many useful applications like chat servers, some PubSub queues, everything that requires a running cluster. This library is also used by several JBoss projects, like Finispan or Wildfly, and of course the products, so EAP and JBoss Data Grid. The library gives you a lot of notification, a lot of different types of notifications. So, for example, you know when the node leaves the cluster, or you can learn when it joins the cluster. So it's very useful. So what can we build using JGroups? First of all, one of the biggest use cases are distributed caches. So you have several nodes, and you have several copies of your data inside of those nodes. This is called sometimes a replicated cache. So we'll take a look at this in detail a little bit later on. You can build with JGroups also a messaging hub. So using this publish-subscribe model, you can basically build some kind of messaging system. But there is a small note right here that if you're looking for a more sophisticated system, you probably should look into some solution which has been designed only for messaging, like Kafka or JMS. So JGroups is only a very low-level, very basic tool. So you need to have this in mind when using JGroups. You can create also with JGroups a replicated state machine. So you have exactly the same state in all nodes. So again, this is this use case can be used when creating a distributed replicated cache. You can also very easily create a task scheduler. So you can run different tasks across the cluster. and coordinate task results, and retrigger recurring jobs, and stuff like that. So there are many, many more use cases, but those are the use cases that were on top of my head. So let's take a look at JGroups architecture. JGroups can be divided into 3 groups, let's say. First of all, at the bottom of the stack, you have protocols, and the protocols define how JGroups act how JGroups behave and act. You can configure your transport there, whether you use TCP or UDP. You can configure how JGroups will find other nodes in the cluster. So this is the most powerful thing in JGroups. The protocols. This is the most powerful thing. The JGroups framework itself basically contains of two APIs. The first one is JChannel. This is the thing that you obtain when connecting to the cluster. And you have also RPC dispatcher. We'll take a look at those a little bit later with some code examples. And on the top of JGroups framework, we have also building blocks. These are much more sophisticated things that can, for example, give you distributed logs, distributed counters, or a replicated hash map. We will also take a look at this a little bit later. So JGroups model and how JGroup behave is very similar to TCP/IP. In TCP/IP model, an application creates some kind of message, sends it through the socket, and then the TCP kicks in, providing transport, and IP providing routing. And at the bottom of the stack, you have your NIC, which is basically your hardware. Then the message is transferred somehow over the wire, and it is being picked up on the other side. So again, it is picked up by the NIC, and again, IP kicks in TCP, and it is finally provided to the application. JGroups behaves in a very similar fashion. Just take a look at that. Your message is created and passed into a channel, and then whole stack of protocols kicks in. And the same happens on the other side. It is being picked up by the transport protocol and transmitted up to JChannel, which is the lowest part of the API that JGroups gives you to program against. So, as I said, those protocols are the biggest power of JGroups. So, unfortunately, we have to take a look at them and do the boring part before digging into the code. So, typically, protocols are defined in XML, and as you can see, this XML is upside down. You have transport protocol at the top part, and all those very sophisticated things are at the bottom. So it is very similar to the stack which is seen by the receiver. So it first gets into the transport and transmitted up. And each protocol has basically 2 methods. It has method up, so pass message up to the stack, and down. It is very easy to remember them. So protocols, let's take a look at them. First of all, at the bottom of the stack, you have TCP. TCP or UDP, depends what kind of transport do you need. A UDP uses multicasting, whereas TCP uses sockets. Next, you have discovery protocols. Those discovery protocols defines how JGroups find other members of the cluster. And you have, for example, a ping protocol which sends multicast requests and listens to their reply. You have also TCP ping, which supports static list of the members. And you have also JGroups custom implementation of multicasting based on TCP. So, for example, if you use TCP transport, then you should use mping, which is a multicast discovery protocol for TCP. Then you have merging. So, when a node leaves a cluster for whichever reason, for example, if a node crashes, it leaves the cluster, and after some time, it's being, for example, restarted, and it joins back the cluster. This process is called merge. And for merge, there is a corresponding protocol, merge3, which actually prepares all the data for other protocol called GMS, which physically joins, the node which crashed a couple of minutes ago. You have also a group of protocols which are responsible for failure detection. And for example, here you have FDAll. FDAll sends a multicast heartbeat and waits for a reply. But in some cases, it is a little bit better to use FDSOC, which collects all nodes into logical ring. For example, you have 3 nodes. Imagine you have 3 nodes. So A connects to B, B connects to C, and C connects back to A. So you have this kind of logical ring, and this ring, each node opens the connection, opens a TCP connection to his neighbor, and if this connection is lost, the node is automatically suspected as failure. So it's very, very neat. You have a group of protocols for stable, NACAC, and Unicast 3, which are responsible for message ordering and stability. So, for example, if for whatever reason a message is dropped and it needs to be retransmitted, one of those 3 protocols handles that. So in 99% of the cases, you should use 3 of them. You have also GMS. As I mentioned before, merge protocol prepares data for merging failure node after it gets rebooted. So physically, the merge is done using GMS protocol. So it handles all group members, leaves, joins, everything which is connected to membership of the cluster. We have also a protocol called UFC, and this is a mechanism called flow control. The same mechanism is in TCP protocol. So if you have a sender and a receiver, and a sender sends messages too quickly, so actually the receiver gets overwhelmed by the amount of messages. So the receiver can ping the sender and basically say to him, hey, slow down, because I get overwhelmed by the messages. So this is what is done using UFC protocol. You have also fragmentation protocol, which basically handles too large messages to be sent. If a message is too large, it is being fragmented and assembled back in the receiver. And you have also RSVP protocol, which handles synchronous sending, because JGroups were created as an asynchronous library. So actually, synchronous sending was added after the fact, after the JGroups were created. We have also state transfer protocols. We'll take a look at those very shortly. So let's leave them. And there are many, many more. Those are the protocols that are very frequently used, and I think those protocols are 99% what you should know about JGroups protocols. Of course, there are configuration parameters, but you should at least know what they are doing. Okay, so the protocols are done. Let's take a look at the API. There are 3 classes that you should know provided by JGroups API. The first one is address. Each member of the cluster has its own unique address. And what's very convenient, this address is a class. It is extended UUID. This is not a string or UUID. This is a class. So you can add additional properties into the address. For example, it is very common use case to add a rec ID to the address, so you know which nodes are collocated in the recs. This can be very helpful. You have also view. View is current list of the nodes, and views are numbered. So let's try to digest what's inside this view. So a node is a coordinator. The view.
That's it. Oh,
Yeah?
sorry. That's not you, it's me. So we've had a problem with this, and it's okay. You carry on.
Okay.
I don't know what happened. Thanks for starting. I'm a bit restricted.
No problem.
Sorry. You can go ahead. Sorry.
Yeah. So let me use the pointer at least for a second. So A is a coordinator. This is the most important node in the cluster right now. Every node can become a coordinator, but right now A is a coordinator. So this is a 4th view. So there were at least 3 changes in a view. So 3 times a node joined the cluster or left the cluster, something happened, and each time a new view is generated. Currently, we have 2 nodes in the cluster, and we have nodes A and B. So this is how you have to read it. And finally, we have a message. This is something that we send across the cluster. And here's how to do it using the API. First, you have to create a JChannel. We'll take a look at this in a second. Next, you have to create a message. Here you have the destination address. So by putting a null here, you're basically saying, send it to everyone. And you're sending hello using JChannel send. So as you can see, the API is very straightforward. Okay, so let's think about what can we build during this presentation. Let's build a chat client. So let's go through the API. Let's talk about each concept, but using some kind of application. So step 1, how to connect to cluster and how to send and receive messages. So let's begin. I have prepared Git repository. I'll share a link at the end of the session. And let me open the first example. Here it is. The first step is creating a JChannel. A JChannel might be created using default constructor, but it might be also created using, in general, URI to the parameters. So here I'm pointing basically my config XML. So let's take a look at this. This is exactly the same file as I've shown you during the protocols part. So we have UDP here, ping, merge. This is basically a copy of UDP XML provided by JGroups. It only contains some very small modifications. For example, I'm binding into my loopback nick, and I'm also using private network multicast address. So let's get back to the code. So the J channel is created. Now the next step is to provide some kind of callback for receiving messages. And you can achieve this by creating a new receiver adapter and passing it into setReceiver method. So let's take a look how this class looks like. This is almost empty implementation of a receiver interface. It is simply empty, not almost. So I'm overriding receive method, and I'm just printing where the message comes from, what's the destination address, and I'm just taking the object that it carries with it. Right here, I'm connecting to the cluster. This is a method that you very often need to invoke during the startup. And we have also our program loop. It basically takes the input from the console, creates a message, and sends it using JChannel. So let's take a look. One very important note. Just to avoid many problems with IPv6, I very highly recommend to use IPv4. Java by default probably will use IPv6, and probably many of you do not have properly configured routing. So just make sure that you append this parameter. In IntelliJ, you can do it right here. Edit configurations and add it in default applications.
So Sebastian, this is a tip for when you're doing development, right? Not necessarily when you're doing production.
We'll have a separate paragraph with troubleshooting, and I'll talk about IPv6 in details.
No problem.
So we'll get back to this. Okay, so I'm running, let's say, 2 instances. Here they are. One instance and the second one. So let's type some message. And as you can see, this message has been received here. In this method. Here and here. So all members received this message. So this was the simplest case that I prepared. Let's take a look at some other details. Let me close that and get back to presentation mode. Here it is. Okay, so now we have learned how to receive messages, but what about views? Now, let's say we'd like to know whenever a node leaves a cluster or joins a cluster. So this can be achieved, again, in receiver adapter, but you have to override another method called viewAccepted. So let's take a look. And even when you start the third node, you get the notification. So new view. Let me mark it this method. We have a new view, and as I said, the coordinator, number of the view, number of nodes, and node identifiers. So let's fire another one. Okay, and as you can see, you got the second notification. So the view ID currently is 1 because I simply started the second node. So let's try with the third one, and as you can see, the view ID is 3. Now let's kill some nodes. And as you can see, after a short period of time, I got another notification, and a node left a cluster. So this is how you can control what's happening in the cluster. Okay, so let's take a look at some more advanced examples. Remember, I told you that you have basically two APIs. First is JChannel, and second one is RPC dispatcher. So let's have a look at the RPC dispatcher. So now the biggest difference between this demo and the previous one is the existence of RPC dispatcher. And RPC dispatcher is created on the top of JChannel, and it is very important to not to use RPC dispatcher and receiver adapter at the same time, because they would steal each other's messages. RPC dispatcher is obviously built on the top of JChannel, and it uses messages underneath. So just make sure that you're not using both. So RPC dispatcher is created based on JChannel, and you have also two other arguments. You have message listener and you have membership listener. Both those classes are implemented by receiver adapter. So you can do a simple trick and override them or create a receiver adapter, but just pass it here if you want to use both. Don't use set receiver adapter on JChannel, just pass it here. So this is how we preserved view accepted, and we also could override the method override. It could also override the receive method just to get the message. It's also possible. And right here, I'm passing the instance that will be responsible for invoking RPCs. So this is how it looks like. I'm creating a new method call, and I'm invoking printout, which accepts a string, and I'm passing there a string from my console. Then on each node, a printout method is called. So this is how it looks like. What is a bit worrying with this approach is that this printout method is connected to the RPC dispatcher very loosely. So as you can see here, you have a string. So really watch out for those during refactoring. Okay, so let's check it out. Let's create two nodes, and let's send something. As you can see, here you have responses, and this is this line. A response list object contains responses from all method calls across the cluster. Because currently printout method returns a void, this would be a response list of a void. But we'll have another example. We'll return an int here. So we'll take a look how to work with response list of a given type. Okay, so any questions at this point?
Anyone in the room got any questions? No, I think it's clear so far. Next question.
Okay, sure. So let's move on. The last demo of this let's say introduction part is how to work with both RPCs and futures. So let's concentrate on the differences between this demo and the previous one. I'm also creating an RPC dispatcher here, but as you can see, I'm using call remote method with future, and I'm getting notifying future in response. Just have in mind that JGroups were created a long time ago, and currently in Java 8 we have a completable future. So this class is not so useful as it was some time ago. But still, you can use notifying future, and you can add some listener just to get notified when this future is done. Currently, you can use some other trick. For example, you can use completable future by async, and then you can return a response get here. This is how you can wrap this and make it more Java 8 specific. You can also call whatever method do you like right here. And of course, you have to throw some runtime exception here. It's a very simple trick just to convert any type of future into completable future.
Sebastian, can you just, before you delete it, can you just explain that in a bit more detail for those that are not familiar with the new Java 8 features, or lambdas in particular?
Yeah, sure. Completable feature, basically it uses the common pool of the fork join. Let me take it back. It uses fork joins common pool. So every new job which is found, it basically uses a fork join pool, which turns out it is one of the most efficient pools if you have very small tasks. So let me show you how to work with this. For example, this notifying future returns an int. So you can then create a couple of transformations in a row. So for example, you can say then accept async, and or even supply async. Just let me see. Okay, so you can, for example, create a consumer here of the int result. Okay, because this returns completable feature. So basically, a completable feature allows you to join a couple of async operations together. For example, you can get the result right here and apply some transformations over it. I don't want to get into the details. One of my colleagues, Tomasz Nurkiewicz, created very nice presentation about completable feature. So you can, it's in English. You can take a look at it in YouTube. So let me move on and just take a look at this offline. Okay, so where were we? A notifying feature. So you get a response. You get a response from a concrete node or from the cluster. And then, as you can see, the printout returns an int. And this is a very simple operation. I'm just incrementing a counter. So let's see how this works. Okay. response get. Response async. Oh, I'm sorry. I didn't get this right. Okay, now it works. Just let me tell you what the problem was. If you add request options async, this method won't block. And in general, if you use futures and you call remote method with futures, just use sync here, because this call remote method with future won't block. So if you specify async here, you're basically telling JGroups not to block 2 times. So it doesn't make really sense. So this is how it works. So let's get back to the slides. So what have we learned? We learned how JChannel works and how to listen to topology changes and how to get a feature from RPC dispatcher. So this can be very useful, especially if you apply a lot of different transformations. But there are some problems of this approach. First of all, it's very verbose, and it's really low-level code, and you probably all feel like a plumbers. So there must be a better way. So let's take a look at the building blocks. Building blocks are the highest available APIs provided by JGroups. So these are like an abstractions created for you, just to not to write the same code many times. So let's get back into IntelliJ and take a look at that. First demo is about state transfer. So as I mentioned before, JGroups gives you ability to have a replicated state machine. So having the same state in all the nodes. And in our case, the state will be the history. So we will have a common history in all nodes. And at some point of time, we'll need to basically log the history. So there are 2 steps during the state transfer. The first is get state. This method is invoked in coordinator, and when a new node joins the cluster, it needs to fetch the state from coordinator. And this method is called to fetch the state. And this is where we need locking, because we need to make sure that nobody won't add anything to the history when we are fetching the state. So this is why we need. This is basically why we need it. The second part is set state method. So this method is called at a node joins the cluster. It takes the state from coordinator and it simply applies it. Okay. So let's take a look at the code and let's find some differences. First of all, we have a channel get state method. So this actually tells JGroups to fetch the initial state. It should be called somewhere close to the connect method. So the second part is printout method, which adds a new text to the history. And the last part is printing out history when you type history. So let's take a look. Let's create a first node and add something to the history. For example, test1 and test2. Okay. So we have 2 elements in our list. So let's create another node. As you can see, a new view was generated, and right after that, we have current history state deserialized. So this newly created node actually invoked succState method. And let's take a look at the first node. The first node became a coordinator because it was the first in the cluster. And as you can see, we have current history state serialized. Here it is. So let's add some more nodes. The third node joined the cluster, and let's check the history state. You can see we have two entries here. So this feature is very useful when you're creating some application which needs to handle common state. And if you have another requirement that, for example, you have to add nodes dynamically to the cluster, so this becomes really first-class feature. Okay, so let's take a look at some other building blocks, because this code is still very verbose. So you have also some classes which basically does all those things with get and set state. They're doing this internally, so you don't have to. And the first one is replicated hash map. So here I have created a word counter. So each time you create a new text, I'm adding a new word and just incrementing corresponding counter. And as you can see, I'm creating a replicated hash map and just passing JChannel to it. And that's it. Oh, I'm sorry. I'm also invoking start. Okay, so let's have a look. Okay, test. And count. You can see when I type in count, it just dumps the hash map. Let's create another node. And let's check the count here. It's also 2. So as you can see, the code is much less verbose. And basically, we have hidden all the implementation details behind replicated hash map. Let's see some more sophisticated building block, and this is called replicated cache. So the difference between replicated cache and hash map is that hash map provides replicates its entries to all nodes. So you can probably imagine if you have 1,000 nodes, 1,000 values in your map. This 1,000 nodes, this 1,000 values is replicated to all the nodes across the cluster. And replicated cache is a little bit more clever, and it actually distributes the values across the cluster. It uses consistency hash algorithm, which is exactly the same concept as all modern data grids basically use. So let's take a look at the rep cache. I'm creating also a word counter, and I even don't have to create a JChannel here. I'm just providing the config and cluster name, and I'm starting the thing up. There's also one small difference. I'm using dump method just to create, just take all the values across the cluster and create a string from it. So let's check it out. Again, test 2 times. And as you can see, we have it's a bit more verbose, but essentially the output is the same.
Sebastian?
Yeah.
I'm just curious, could you do atomic updates to this distributed, this replicated object that you've got? So the word counter.
To be honest, I think it is implemented in replicache, but I have no idea how. I would have to check the code.
Oh, sure, no problem. Yeah, so the thing, in particular, thing I was looking at is that you do a get on the cache, then you increment the value, and then you overwrite the cache. So presumably there's race conditions there where other parties could be updating the cache.
Mm-hmm. To be honest, I don't have any answer at hand. I would have to I just note it down and try to come up with answers.
Maybe this is maybe the question I'm asking is kind of more than what JGroups is doing. JGroups like a LinkedIn level communication.
Oh, I'm sorry?
Maybe the question I'm asking about atomic update is something that you would build on top of JGroups rather than being provided by JGroups. I'm not sure.
You have also, if you need atomic updates, you have distributed log on JGroups, so you can easily create an update. They won't be atomic, but they will be consistent. I would need to check the code. I don't have answer on top of my head.
That's no problem if you don't know. It's okay.
Paul, can you just?
So Tom would let us know. Can you speak up, Tom?
I don't know if you'll be able to hear me from the back. Is there like anything on the word counter where you could do something like word counter.lock, which would like lock it across the cluster, and then word counter.unlock? I'm just thinking with Paul's thing where he wants to basically synchronize that object in different JVMs, really, is what you're asking. So I'm just wondering if there's some construct in JGroups that allows you to do a site-wide lock on the object. This looks like it may be related.
Yes, it's not mentioned on my slides, but basically there is something like log service in JGroups. You provide a JChannel to create an instance of a log service, and you can obtain a log, which is standard Java 5 log implementation, and this is a distributed log. So it's not on my slides, but yes, you could use it.
So that way you could call the lock, and then you could do the get and the set, and then call the unlock.
Yeah, definitely. It would be even better approach than mine.
So I don't want to derail it, but I have a question about cap and partition tolerance. But we can talk about that after, like when we get to the end.
Sure. If this is a long question, we can wait till the end, and if it's the short one, we can take it right now.
Does it solve cap?
Oh. Oh. Okay, let's take it at the end.
I think we could tease it to make people watch till the end. I guess no.
I should have created a presentation with InfiniSpan so I could answer those questions. JGroups are really low-level API, so all kind of state transfer, partition handling needs to be, you need to implement this by yourself. It is implemented in InfiniSpan if you'd like, but in JGroups, nothing. As you can see, you have only callbacks when a node leaves or joins a cluster. So everything apart from that, you would have to implement by yourself.
The reason it relates specifically to this is get lock partition tolerant.
I don't think so.
No. Okay.
Well, I think we're too high a level. I think JGroups is lower.
Yeah, there is a get lock method that's provided, so it's not partition tolerant.
Yeah. So when does it lock until the partitions?
Yeah. Just keep in mind that JGroups are the bottom of your stack very often. So this is the framework that you implement, that you use. You use JGroups to implement all this kind of abstractions, just to provide partition tolerance and implement how to react on splitting and etc.
I have one question.
Go ahead.
Hi there. I was wondering if there's a mechanism for acknowledging kind of read-receive, if you like, and how that works in a multicast use case where some of the nodes may have gone down. Does it keep any kind of list of who's been on the other end and received it, or is that just lost forever?
Yes, there are basically there are three protocols responsible for message stability. This is NAC Act 2. It provides negative acknowledgement. So JGroups don't use positive X. It basically uses negative X with some corner cases. For example, what happens if a node simultaneously leave and joins the cluster and stuff like that. There are some very fine-grained corner cases, and basically it doesn't support. So basically, you get a retransmission, but when your node when your node fails and it gets excluded from the cluster, it's done. You won't get any messages. It needs to be joined to the cluster. So
if it disconnects and then subsequently rejoins, is there not a mechanism to pass it what it missed in the meantime?
No.
That's a simple answer.
Yeah, I think that's probably a high-level thing you would build on top of JGroups.
Yeah, if you're not in the cluster, you won't get it.
Sure, understand. Thanks.
So this is what makes JGroups different from messaging frameworks, from pure messaging frameworks. Because in messaging frameworks, you will eventually get the message. At least you should. But in JGroups, if you're not in the cluster, you're out.
So I imagine you could build a JMS service on top of JGroups.
Yes.
Is that, I don't know if this done? You know, do people use JGroups? I don't know if FindingQ is based on the JGroups, so.
Sorry, I didn't hear that precisely. So JGroups, I don't know if FindingQ use JGroup, but I'm not sure. But you know, this is not a messaging framework. So all those high-level features needs to be built on the top of JGroups. They are not embedded into JGroups itself. It's like a clustering framework only. So if you have a net of nodes, all you can do is communicate with them. You have no real messaging. If you're looking for real messaging system, you should probably pick up JMS or Kafka or whatever.
Yeah, that makes sense. Which may well be using JGroups underneath.
Mm-hmm. Yeah.
Yeah, that makes sense.
Okay. So let me get back to the slides. What have we learned? We took a look at some building blocks. There are many of them, but I only included 3 in my presentation, and most of them provided a replicated state machine. And I'm not sure if you have noticed, but the example with the history is actually an implementation of a replicated cache, because you could very easily replace the list of strings which served as a history in our example with a hash map, and you have a replicated cache. So each of you right now can write a replicated cache. It's pretty cool. We have also we took a look at some really high-level building blocks like replicated hash map and replicated cache. But again, if you need an advanced caching solution, you should probably look into InfiniSpan. Again, JGroups is a very basic, very low-level framework. So we have also discovered some problems. with those high-level building blocks, we lose control over the messages that we're sending. So, and there are also problems with JGroups. And there are a lot of problems, especially in our mailing list, and also we receive a lot of emails and requests from GSS. So let me just go through the issues that recur a lot. So first of all, cluster falls apart. Probably sometime you can see that your nodes are forming a cluster, and after some time it falls apart, and then again several seconds it forms again and again falls apart. So in those cases, very often you have misconfigured FD or FD all timeout. So these are the fault detection protocols, and they, in this or another way, they use heartbeats. If for example, you have a really long garbage collection, you won't be able to respond on a heartbeat, and you actually get suspected, and eventually you get out of the cluster. So have in mind that you probably, in this case of really heavy traffic, thread pool, if your application consumes a lot of threads, and if you have a long garbage collection pauses, you probably should increase your timeout. There are some routers which have been diagnosed and contains several bugs, especially with multicasting. So if you see that something really fishy is going on your network, just make sure that you're using the latest framework of the switch. Sometimes it happens that your NIC is faulty, and it also can make your cluster fall apart. So the second issue that is very frustrating is that all nodes are connected, everything is booted up, but the cluster is not forming. So what are the probable causes? You have used wrong bind address. So let me just go to IntelliJ. I'll show you where it is. It is config XML. Here it is. You're binding to some address. Normally it should be an IP address, but there are some global constants like a loopback. You can refer to JGroups documentation to find them. So just make sure that you're binding to the correct interface. You might bind to wrong NIC. This is also very frequent. And there are some firewall issues. And as I said, your switch might be dropping multicast packets. So it can happen. It happened in major companies that had misconfigured their network, and all the routers were dropping multicasting packets, and they were trying to use UDP. So in that case, you have to switch to TCP. This is the easiest workaround. And in very large topologies, sometimes you have to increase the time to live of the packets. There are some configuration errors also in JGroups. So just make sure that if you upgrade JGroups framework in your application, just take UDP or TCP XML and apply all your changes once again. I know it is sometimes very hard to do, but it's much better solution than to have an obsolete configuration, because JGroups Bella constantly modifies those configuration parameters in JGroups, so it is a very good idea to use the latest one. Sometimes it happens that you put a protocol in wrong place. So it simply can happen. And this one I left as is, so don't try to be smarter than Bella. Sometimes some solutions are not so obvious. For example, if you use TCP, you might think that TCP supports retransmission, so you probably won't need unicast, which actually does retransmissions of the class when you're in cluster. For example, if for whichever reason some messages are dropped, JGroups will ask to retransmit them. And actually, there is a logical connection between those two, and your messages, because TCP makes sure that the order of your packets is okay, but it doesn't mean the order of your messages is okay. So just have in mind that don't try to remove unnecessary protocols. Just think twice. You have there's also a case when someone used TCP and removed stable, and it turns out that TCP and stable is also logically connected, and it resulted in a memory leak. So just if you remove some protocols, do it step by step and test your solution after each step. Do it very slowly. It also happened in the past that one of our clients used different versions of JGroups in the same cluster. And of course, there were some problems with that. Also, as I mentioned before, just copy the most recent configuration and apply your changes once again. Okay, IPv6. In general, JGroups work with IPv6, but in most cases, you probably don't have configured correctly routing in your laptop. It is very frequent. So if you use IPv6, just make sure that you have properly configured routing. Also, do not mix IPv4 and IPv6 in a single network, because JGroups JGroups nodes won't find each other. And when in doubt, just use IPv4. Note that very often JGroups-based applications are used behind some firewall inside your network, in your DMZ. So actually, IPv6 is not a big deal for JGroups. You very often can use IPv4 without any problems. So now we took a look at the problems. Now, how can we diagnose them? First of all, make sure that you have enabled and you're using JMX. So this is the magic word that you need. You need to get the platform ambient server. It might be a little bit tricky in application servers, but in standalone applications, you can get the platform ambient server, and you might use a JMX configurator. Just take a look at it. Let's take a look at it at example. Let me switch to presentation mode, and I have a small demo here. This is our first application. As you can see, it has the receiver applied right here. And what's different is that I'm creating an ambient server. I'm registering a channel. So let's try it out. Application is up and running, and now we need some software to connect to the ambient server. Let me run JMC, for example. And you can use also JVisual VM or JConsole. So whichever tool do you like. I prefer JMC. So right now we're connecting to Ambient server. And here we have Ambient browser. And as you can see, you have a new element in JMX tree. And here you have all protocols defined in your XML. And now what's very convenient is that most of those variables are actually writable. So for example, if you have ergonomics, this is a property that JGroups use to adjust its pool sizes into current environment. So if it gets wrong for some reason, you can just turn it off. And in most cases, if the property is writable, the effect is immediately. So it is very, very handy. Okay. So, but there is a better tool. JGroups has also a tool called probe. This is a Swiss Army knife for JGroups. You can actually debug running cluster. You can extract all JMX information, and you actually can set JMX values live on your running cluster. So this tool is, a must-have if you actually run JGroups on production. So let's take a look. Let's take our first application and create a couple of nodes. Okay, 3 of them should be enough. Now, if you download JGroups repo, you have a bin directory, and you have a probe sh. This is your entry point for probe. But you can also use the class. So let me navigate to probe, and let's start it without any parameters. Okay. So as you can see, probe discovered 3 running nodes, and you have the address of the node, cluster name, current view. This is really helpful, and you have physical address, and also version. I assume you won't have multiple versions inside of your cluster. Okay, so now let's do something more advanced. Let's extract all JMX values from running cluster. And for this, you just need to you just need to add one argument to the program. It's called JMX. Okay, and let's run it. Okay, here it is. As you can see, it printed out all values from each node. You can also use JMX space and just name the protocol, name the value, and set a new target value, and it will immediately invoke JMX operation across the cluster. It's very, very useful if you're actually debugging the production. Okay, let's get back to the slides. So if you're interested in JGroups, you can take a look at our JBoss forum. You can also download the code from GitHub and just run a couple of examples yourself. These are the people that I've stolen my images from. Okay, so thank you very much, and let's have some questions.
Thanks, Sebastian. That was really interesting. I think we probably asked most of the questions as we were going through, but I'll just give people another opportunity. Anybody got anything else they wanted to ask?
Yeah. Can I ask?
Yeah,
I see. Thank you for the presentation.
Yeah, no problem.
Yeah. When JGroup is changing view because of the node crash, does JGroup block a client from sending requests to the healthy node?
I'm sorry, I barely could hear you. Paul, could you please repeat the question for me?
Okay, so I'm asking about the group membership in JGroups, right? When the node leaving and joining the cluster.
Oh, yeah.
If the JGroup is changing the view from view 1 to view 2, right?
Mm-hmm.
At the time, does JGroup block the clients from sending requests to the correct nodes?
Okay, so let me just tell you how JGroups detects that the node should be removed from the cluster. JGroups basically does this in 2 steps. At the first step, when the failure detection protocol kicks in, it suspects the node. So it probably is down, but it needs to be verified, and this is step 2. This is typically done by the coordinator. So each node can suspect, any other node, but the coordinator validates if the suspect is really down. And if the coordinator validates that the node is out, it sends out the new view. So if your node is down, but it will respond eventually to the heartbeat, it won't be eliminated from the cluster. All messages will be retransmitted to this node. However, if your node is out, so it has been affected, it has been verified as down, it has been eliminated from the cluster, then it's not a cluster member. It won't get any messages. Did this answer your question, or not exactly?
Yes. Let me add something more, right? So
Mm-hmm.
assume is the node, one node. We have three nodes cluster, right?
Yeah.
If the node number 1 is crashed, right,
Mm-hmm.
and the 2 other is still working, right, and we have a lot of clients at the moment sending requests to the cluster,
Mm-hmm.
right, and because of the one node crash, the JGroups will do the view changing, right?
Yeah. Mm-hmm.
At this time, does JGroup allow the clients handling requests, or will the JGroup block the client from sending requests?
They will allow the sending information to the clients. But once basically all nodes use the same algorithm to choose new coordinator. So each node can send a new view, and each node can actually become a coordinator. So no, they won't stop. They will keep serving the data, but after some time, a new view will pop up and new cluster will form.
Sorry, we were muted just then. So I think there was. So it answered your question, and you were saying thank you.
Yeah.
That's what we missed. Okay. Are there any other questions in the room? No. Okay, and there isn't any more questions on the IRC either, so I think we're done here. So thank you very much. Thanks for this presentation.
No problem.
Thank you. Okay, we'll go now and go and have our beers and pizzas.
Oh yeah. the most important part.
All right, thanks.
Okay, it was great to meet you.
You too, thanks, bye.